afternoon. So today we will present our video presentation on EAB 3208, which is Agricultural Waste Management. So we are from Bachelor of Agricultural and System Engineering Semester 2. So we will introduce ourselves. My name is Robert Ading Alemong. My matric number is 208575. So next.
Next is Anel Kadau Anapupo, and my metric number is 208569.
And me, Muhammad Adib Azri bin Habari, and my metric number is 209063.
Okay, so we will move to the next presentation, which will lead by Adik.
Okay, firstly, I would like to present and explain about the Department of Environment, or as known as DOE. Department of Environment, DOE was originally created as Environment Division under the Ministry of Local Government and Environment on 15 April 1975. Environment Division was then placed under the Ministry of Science, Technology and Environment in March 1976. Based on the importance of environmental protection and conservation, on 1 September 1983, the Environment Division has been upgraded to a department known as the Department of Environment. On March 2004, DOE was then placed under the Ministry of Natural Resources and Environment. The, the establishment of Department of Environment is based on the Environmental Quality Act 1974, which was enacted in March 1974 and came into force on 15 April. Um, Back to the previous slide. Okay, the establishment of Department of Environmental is based on the Environmental Quality Act 1974, which was enacted in March 1974 and came into force on 15 April 1975. The main function of the Department of Environment is to prevent, eliminate, control pollution, and improve the environment. Department of Environment also responsible for the implementation of the resolution decided by the Convention of the International Environment. The vision of DOE is environmental conservation for the well-being of the people, while the mission is to ensure sustainable development in the process of nation building. This is the regulation from Department of Environment. As you can see, firstly, environmental quality prescribed premise, schedule waste treatment and disposal facilities regulation from 1989. Then environmental quality sewage regulation from 2009. Environmental quality control of pollution from solid waste transfer station and landfill, which is regulation from 2009. The environmental quality industrial effluent regulation from 2009, and environmental quality schedule waste regulation from 2005, and lastly is the environmental quality prescribed premise raw natural rubber regulation from 1978. Next. Next, I want to explain about the Drainage and Irrigation Department, or as known as DID. DID is a department established to control irrigation and drainage systems in development, including agriculture. DID provides professional services with quality through planning, design, implementation, and management of all drainage and irrigation projects. The scope of enforcement of DID include river basin management and coastal zone, water resources management and hydrology, special projects, flood management, and lastly is eco-friendly drainage. The objective of Department of Drainage and Irrigation is to provide engineering infrastructure to assist the state to achieve the policy of self-sufficiency. It's also to plan and design of new land development scheme which are efficient, sustainable, and economical to support agricultural activities. The ID also provide professional and technical service efficiently in matters related to water management and land development to support agricultural activities. The ID also introduced modern practice and advanced technology in drainage and irrigation areas. Besides that, the ID do the rehabilitate and upgrade existing facilities in order to enhance the function of existing the ID scheme. And lastly is the ID is operate and maintain the existing the ID scheme to ensure the infrastructure can be function efficiently and effectively. Next. And this is the act that related to agriculture activity from the Department of Drainage and Irrigation. First is Third National Agriculture Policy, Irrigation Areas Act 1953, Drainage Work Act 1954, Waters Act 1920, and lastly is the Fisheries Act 1963 or Inland Fisheries Act. Next, I would like to pass the presentation to Robert Radin.
Okay, thank you, Adi. So I will present the second question on our video presentation, which uh, on news on the waste disposal into river or surface water in Malaysia. So the news is entitled Penang Government Form Task Force for Polluted River in Batu Mau. In this news, there are two rivers facing pollution in this area. One is Sungai Keluang, where foaming has been observed due to illegal discharge of this river. Second is Sungai Nipah, with recycle companies, restaurant, and residents near the river has been using a dumping ground. He said in a press conference at the riverside in Kampong Naran Batu Maung. So okay. So in this news, these are the impacts on the surface. First is color and turbidity. Okay, the color and turbidity of the water are affected when there is contamination. Typically, tannins are formed from organic materials and include branches, soil, fish, debris, and more. The types of tannin will depend on the location of nature of the contamination. Some are difficult to see, so every regular checks of the water supply is important. Turbidity occurs when there are sediments in the water which typically settle or cloud at the appearance of the liquid. This is not necessarily harmful. Turbidity is more common in surface water as it lacks or the natural filtration found in groundwater. So the second one is pathogen in surface water pollution. One of the biggest risks to human from surface water pollution, uh, pathogen that can that cause type of waterborne diseases. These come from human waste as well as industrial sources, which include organic chemicals and heavy metals. So the last one is surface water full with solid waste. As you can see from the picture above, there are lots of solid waste, especially from our water waste, from our food waste. So by with the significant amount of waste on the surface of the river, it will decrease the oxygen absorbed by the living things that live in the river. So it will leads to the living thing will die. So this is the groundwater. Groundwater get polluted when contaminated. Often, the people who rely on the water most are unable to pay for expensive cleanup measures due to uh, need a lot of time to clean up the groundwater. So, groundwater can also separate contamination far from the original polluting source as it seeps into stream, lakes, and ocean. So, when groundwater is contaminated, it will it can call as a connectivity. It will connect others and separate all the contamination in it. So when groundwater is contaminated, it will decrease the water source for people that living, especially people that living on the rural area where their main sources is groundwater. So next is human health. Okay, human health. First is ingesting microplant. Uh, a person may ingest microplant via drinking water or through eating contaminated seafood. At Tokyo Bay in 2016, scientists examined 65 attributes for microplastic consumption and 77% at microplastic in their digestive system. So next is consuming water contaminated by sewage. The the globally, according to research, globally around 2 billion people use a drinking water source with uh, contaminated source. Contaminated water can harbor bacteria such as those responsible for diarrhea, cholera, dysentery, typhoid, hepatitis A, and polio. So next is drinking water containing chemical waste. Chemical pollutants such as pesticide, fertilizer, and heavy metal can cause serious health problem in ingested. For example, when people in America experience water contamination due to inadequate testing and treatment of their water supply, the contaminated water can cause rashes, hair loss, itchy skin, lead level in those bloodstream of children who drank the water double. So the last but not least is the ways to maximize this pollution. First is to avoid using garbage disposal, keep solid waste solid, make a compost pile from vegetable scrap. Second is do not flush pills, liquid or powder medication or drag down the toilet. For recommendation on proper disposal for all types of medical waste. Third is minimize the use of pesticide, herbicide, fertilizer, and do not dispose of this chemical, water oil, or other automotive fluid into the sanitary, sewer, or storm sewer system. So that's all from me. I will pass to the next presenter, which is Anelka.
Thank you, Robert. So for third task is the waste characteristic from rubber plantation and industry. So there are four uh, four major environmental. Next slide. So there are four major environmental problems. So for the first is high concentration of BOD, COD, and suspended solid. So next is high concentration of ammonia and nitrogen compound, uh, high level of sulfate, and last but not least is acidic effluent. So for the high concentration of BOD, COD, and suspended solid, the main source of the pollutant is coagulation serum, field latex coagulation, and skim latex coagulation. So these compounds are readily biodegradable, and this will result in high oxygen consumption upon discharge of wastewater in receiving surface water. So for the high concentration of ammonia and nitrogen compound, the high concentration of ammonia present in the latex concentrate effluent pose another serious threat to the environment. So most of the concentrated latex factory discharge the treated wastewater with content high level of nitrogen and ammonia to the nearby river and leading to the water pollution problem. So if the high level of ammonia is discharged to the water body, it could lead to death of some aquatic organism in the water. So high level of sulfate, uh, the explanation is the effluent from the latex concentrate factory contain high level of sulfate which originated from the sulfuric acid used in the coagulation of skim latex. So the high level of sulfate in the process can cause problem in the biological anaerobic treatment system as high level of hydrogen sulfide will be liberated to the environment and generated another problem. So the free hydrogen sulfide also inhibit the digestion process, which give lower organic removal efficiency. So for the acidic effluent, so this is due to the use of the acid in the latex coagulation. The effluent discharged from latex rubber factory is acidic and redissolve the rubber protein. So the effluent comprise mainly of carbonaceous organic material, nitrogen and sulfide. So next is the treatment method. Treatment method for the waste product from rubber plantation. So there are two common treatment, which is pond technology and aerobic and anaerobic treatment method. So for the pond technology uh, is a widely used method for the treatment of effluent from the rubber industry in Malaysia. So the pond system usually include high loaded anaerobic pond and low loaded aerobic pond. Before the pond treatment system, there is a latex trap and a neutralization stage as a pre-treatment step. If the pond are effectively designed and optimally operated, it can remove over 95% biological oxygen demand from rubber wastewater. So if effluent with BOD level of 50 to 100 milligram per liter can normally be achieved by this method. So basically this method is can maximize the removal of biological oxygen demand. So for the aerobic and anaerobic treatment method, so this method is also give the greatest reduction of BOD. So the aerobic and anaerobic treatment is the most common biological method that used in Malaysia for treating rubber wastewater. And this method also is an inexpensive treatment with high efficiency. So in rubber factories, where land area is limited, aeration systems are used as an alternative of stalling pond. So conventional treatment systems are well set up using aeration system with sludge recycling to increase the microbial concentration in the aeration tank. So this method also can remove over 95% of BOD from the rubber wastewater. So this system can overcome molder problem and suitable for factory with inadequate land area. So the existing system was not effective in removing nitrogen because of an insufficient supply of dissolved oxygen for nitrification. So as an alternative method, uh, to increase the effectiveness of this this aerobic and anaerobic treatment method. So the Rubber Research Institute of Malaysia (RRIM) use the biological processes for the treatment of rubber factory effluent. So they choose the coconut fiber as a new medium for the rubber waste treatment. So the availability, high specific surface area, high water holding capacity, and a balanced C and P ratio of coconut fiber are favorable characteristic for biofiltration application. So this method have been improvised improvised for the rubber wastewater treatment. Next is treatment method, the biological treatment method. So for the first is biological azola as a biological treatment. So basically this using the tiny floating fern, which is the azola species for treating the wastewater from sugar refineries and rubber processing plant in Malaysia. So the result will extraction uh, will will extraction of the compound containing nitrogen. So next is water hyacinth as a biological treatment. So this is a plant such as water hyacinth used for treatment of Malaysian rubber sewage and recovery of dissolved nutrients. So the result will met a reduction of 99 to 80% of BOD and COD. It also declined the suspended solid of treated wastewater to the less than 50 milligram per liter using combined system. So this method more efficiency of combined algae and water hyacinth system for removal of nitrogen as compared to the normal high rate algal pond. And last but not least is the ammonization system. So this method is used for removal of ammonia from skim latex using a salted plate system and a new deammonization system known as Potrim that was developed by Rubber Research Institute Malaysia. So the result is to overcome some problem encountered with salted plate system, provide more efficient deammonification and effective cleaning using Potrim. So that's all from me. Thank you.
Okay, thank you all for participating in this video presentation. So that's all from us. Thank you.
Thank you.